All right, check this out. It goes up to 6, but the quizzes didn't go all the way, right? So, did we go over the last quiz? I don't know. Let's just do this. Ready? I'm looking at the test, got it right in front of me. I'll tell you what to expect, what not to expect. So numbers 1 and 2, definitely know how to do that. How do you do that? The sum of the interior angles. I'm not going to do like every single problem for you, okay? You guys are honors. You could do that yourself. But I'll give you a starting point, okay? How do you find the sum of all the measures? Do you remember the little formula? N minus 2 times 180, all right? So it says now the one on the test may not say octagon, and I'm looking at it right now, and I'm telling you, it doesn't say octagon. There's another polygon that I give you right here, okay? So, but what would you do if it was an octagon on this quiz? So it's supposed to be an n minus 2 times 180. So what would you do? 8 minus 2 times 180, and then whatever that is. I should have these memorized by now, to tell you the truth. I've done this so much, but I don't. What's 6 times 180? Do I got a calculator out? 1 million? Don't think it's a million.
1080.
1080? Yeah, that's right. That sounds familiar. 6 times 180, just making sure. Yeah, so that would be 1080. I thought I said I wasn't going to actually do these problems. Now I'm doing them. Okay. This one says a regular decagon. How many sides is a decagon? 10. So what would you do? 10 what?
10 minus 2 times 180.
Right? But this says what? Find each interior angle of a what? Regular decagon. So if it's a regular decagon, this doesn't say regular up here, does it? So this could be all kinds of crazy angles, but you know you have 8 sides, okay? It doesn't have to be a stop sign, right? Stop sign is a regular octagon. So this could be anything if I just add up all the angles. But this one, in order to find each angle, I got to know that each angle is the same. And that's what regular decagon means. So I take 10 minus 2 times 180. Then what do I do? Divide it by 10. That's correct. And then whatever you get, I'll let you get that. Okay? Again, I'm not going to go through every step on these problems. I'm just going to set them up for you. All right? No, it could be on the test, but I'm just not going to do all the algebra and arithmetic, okay? So this is a rhombus. So what does that mean if it's a rhombus? All the sides are equal. So how would I find every one of these sides? Set these equal to each other. 3x minus 9 equals 2x minus 4. Do your math, solve for x, then do what? Plug it back in to either one of these. It doesn't matter because they're both the same, aren't they? All right, so you plug it in, and then each one of these is the same. I don't have the quiz out in front of me, so I don't. 6? Okay. All right. This is why you shouldn't throw your quizzes away, by the way. And you guys don't usually do that. You usually hang on to stuff. The CP classes, I'll give them a test or a quiz back, and then they all leave, and I look at the trash can. There's like half a dozen quizzes sitting in my trash can. I was like, why would you do that? Because you know that's going to be on the test, right? But anyway, so hang on to them. What about here? This is a trapezoid. It's not just any trapezoid. It's a what? So what do I know about this being an isosceles trapezoid? That means this is equal to this. So just like this one right here, I would set these equal to each other, correct? Solve for P, plug it back in, and boom, you got KJ and you got LM. They don't even ask for KJ, do they? Oh yeah, it is. KJ, JK, same thing. Right? So that gives you this one, and LM, that would give you that one. So those two are going to be exactly the same, correct? All right. And then once I know P, you already found it by finding those two, then you plug it in for that, and you plug it in for that. Super easy. You got all 4 of them. No biggie. Good? Seems like we went over this not too long ago. Didn't we? Maybe it was longer ago than I thought, but it seems pretty recent. All right, let's do this. Find angle P, this angle right here. Oh, I could find that without doing any math at all. Why is it 117? They're not exterior. Look, I got parallel lines. Okay, because look, these two are equal to each other, or they're both 90 degrees. That must mean it's a trapezoid, which means those are parallel. I got two parallel lines. You see that? Cut by a transversal. So these are alternate interior angles. So that would also be 117. What about this? I got all x's, so it's kind of easy. Yeah, well, let's not say set them equal to 360. You got to do something to them before you set it equal to 360. What do you have to do to all four of these? Add them up, right? Okay, so you add up all four of these, set it equal to 360, solve for x, plug it back in for right there, and you got angle P. Everybody see that? All right, because on a quadrilateral, all the angles add up to 360 degrees. We good with that? All right. What about this? This is a parallelogram. So, I don't know, NE, oh, okay. So this angle right there, yeah. So this angle right there is equal to that angle right there. Agreed? So if that's x degrees, what's this angle T? X degrees. But that's not really what they want. They want an actual measurement, okay? So you're going to have to solve for what? For x, okay? So now, knowing that the opposite angles of a parallelogram are equal to each other, if that's x, what can I do? This, and this. What happens to all three of those? They add up to 180, right? Because they're angles in a triangle. So what's the math? You add them all up, set it equal to 180, do some algebra, solve for x, and bam, that's your angle right there. Make sense? Okay. What about NE, this line segment right there? Well, it's a parallelogram, so you know that what? The opposite sides of a parallelogram are equal to each other. So that's 5y. This is 3y plus 8. What can you do with those? Set them equal to each other. That's right. So they're equal. So you set them equal. You solve for y. You plug it back in. And then you got NE. We good? Okay. I don't know. This is going pretty good. Maybe we should have the test on Monday. Find each measure in this. Okay, so find QR. QR. That's this right there. So what are we going to have to do? Now, this one's a little trickier. The math is a little trickier on this one. So this is what I got to find. I got to find that 2y plus 1. So I got to find y, don't I? So how would I find y? What do we do over here? We just set the two opposite sides equal to each other. But there's a little bit of a problem with this one. Because look, they're still equal to each other, but what's the issue? Yeah, this has an x and that has a y. That's a problem, isn't it? Yeah, it's not that much of a problem. Let's set it up. So x plus 3 equals what? 2y plus 1. Would you agree? All right. But I can't solve for y right here because I got an x there. So what else do I got to do? Well, what's true about these two sides? They're also equal to each other, aren't they? So I could write what? X, this is just x right there. So x equals what? Y plus 2. And now we just have to do a little bit of math. The math isn't too hard. What math is it? What's the name of it? Substitution. Good. So x is equal to y plus 2. And this x and this x are the same x. This y and this y are the same y. All right? So if x equals y plus 2, what can I do with that? Make that a what? Make it a y plus 2. And then continue the rest of your equation. So what's the rest of it? Plus 3 equals 2y plus 1. I'm not going to do the math for you. You can do it yourself. Okay? So you solve for y. Once you solve for y, you can plug it in for that, and you got QR. That's what they ask for. Make sense? Okay, good. Now, they change some things up, but it's basically the same thing. They tell you, well, it's not the same thing. I'm sorry. Let's do different colors. Let's go, can you see that light blue if I draw in light blue? Yeah, it's pretty good. All right, so what do they tell you? PV. So this is what? A plus 1. And VR, that's this one right here, is 2B. All right. What do we know about the diagonals of any parallelogram? What do they always do? Yeah, they intersect, but more specifically, they bisect each other, okay? It's true they do intersect each other, but there's more to it than that. Okay, they bisect each other. So that means that PR, talk to me, is equal to, right, SQ or QS. You with me on that? They bisect each other, which also means that PV, it's being bisected, isn't it? That whole PR is being bisected. So what's true about this and this? They're equal to each other. But again, I got a little problem, don't I? Because I got an A and a B, but you're going to do the substitution very similar to what you did over here. All right? They tell you some other stuff too. QV is A minus 1, because you got to know this other information, and VS is B plus 1. Does that mean that this 2B and this B plus 1 are equal to each other? No, not at all. All right? So again, I'll set it up for you. You do the math. So A plus 1 equals what? What is it? 2B. Good. So these two are equal to each other, and what else? These two are equal to each other. So what is this? A minus 1 equals what? B plus 1. And now you can do some math. You could do it by substitution if you wanted to. You could get A by itself, couldn't you? So subtract the 1, so you could get A equals 2B minus 1, and then take that, put it in for here, right? And then you could solve for B. An easier way would be this. This is set up perfectly to do what? We talked about this. Elimination, that's right. So look, it's set up perfect. Why? Because the 1 and the negative 1 are right on top of each other, and the A and the A. So what am I going to do? I'm going to add up all my columns. What do I get? I get 2A. What happens here? Actually, I'm sorry. I lied. It's not what I want to do. I was thinking something else. But I would do it the way I initially said. You could solve for this A if you wanted to, or you could solve for this A. It doesn't make any difference. Let's just solve for the top A. So what would I do? Subtract a 1. So what's A equal to? 2B what? Minus 1. So that's what A is. So I'm going to take that A and substitute it in for this A right there. You see that? All right. Sure? So instead of A minus 1, what are we going to write? No, it's not an A now. What we're substituting? We're taking this, we're replacing that A with this. So what is it going to be? 2B minus 1, keep going, minus 1, because of that minus 1 right there, equals B plus 1. I'll let you do the rest. You solve for B, and once you get B, you can put it in, and what do they ask for? PR? Yeah, so I would put it in for this one right there. Once you get B, put it in for this, and then whatever length that is, this length right here is the same thing. So really, what are you going to do to find that whole entire PR? You're going to take whatever that is and do what to it? Double it, right? And you got PR. Are you getting this? Or are you just nodding so I just keep going and you don't know what I'm talking about? Locked in? Good. That's what I like to hear. Everybody good with that? All right. Now, somebody write in their notes. Write in their notes that we're going to cover 6.3 and 6.4 on Monday. All right? Because I probably won't remember. But we will review on Monday some more. And we'll also do 6.5 and 6.6 a little bit. We basically did 6.6 already earlier before I started recording when we did that one with the rectangle. Okay, so we really don't need to do that because that's what's going to be on the test from 6.6. Okay, but we will review this quiz, 6.3, 6.4. We'll go over 6.5. We did not have a quiz on 6.5, all right, but we can go over some questions you might have on that. And you'll be good and ready for the test on when? Tuesday. Go Birds.